This is Homelink 5.7 of Everyday Math, Understanding Decimals. Your child has been using grids, like the ones below, to understand the meaning of decimals. The grid is made up of 100 squares. Each square is 1/100th, or 0.01 of the grid. 10 squares is 1/10th, or 0.10 of the grid. 0.8 is read as 8/10ths. 0.04 is read as 4/100ths. 0.53 is read as 53/100ths. Students are most familiar with the way this looks in terms of money, and this is how I've tried to help them think about it. If you see something that looks like this here, and we're talking about money, most of the students can tell me that this equals 4 cents. Well, students know that there are 100 cents in a dollar, so they've sort of been thinking about the dollar as equaling 1, because $1 equals $1, and then it also equals 100 pennies. And so students are familiar with dollar and cents notation, where they have seen it written as 0.04 before, with a dollar sign in front of it. So this is sort of like the pennies, or 4/100ths of a dollar, which is written right here, 4/100ths of a dollar. And immediately, when students began to think about that this way, they knew that this is like 53 cents. It doesn't equal 1, it's less than 1, because the numbers are to the right of the decimal point. All these numbers to the right of the decimal point are less than 1. So they know that this is 53 little parts of a dollar, or 53/100ths is the way that is read, because altogether that dollar would make 100 pennies. That's just one way we've talked about thinking about decimals. So we have grids down here. If the grid is 1, and they can think of these as their pennies, so the grid is $1, then what part of each grid is shaded? Write a fraction and a decimal below each grid. So another way to think about this too is with these flats here. Each flat has 100 squares in it, or 10 longs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and each long has 10 cubes. I could line these cubes right up, and it will equal 1 long, because there are 10 of them. So these cubes are like my pennies, if I'm thinking of it in terms of money, and the longs are like my dimes, and the flats are like my dollars. Okay, so if I were to look at that this way, I have $1 on the bottom, and then I have 10 cents, and then I have 10 pennies, which is $1.20. Okay, so just to kind of break that down a little bit and help us think about it this way. So I'm going to be looking at my dollar here. Well, if I look at this, I see this row is all shaded here, and I know that's 10, so there's 10 there. This row is all shaded, and I'm just darkening it so we can see a little bit better under the camera. And there's 10 there. And this row is all shaded, so I'm going to darken this up too. So I know that I have 3 sets of 10 shaded. Okay, so I'm going to just kind of take a look at it here. I have 3 sets of 10 here. 3 longs, or 30 pennies. So this much of my dollar, or this much of my 1, is shaded here. So for the fraction, I know that I have 100 on the bottom, because I have 100 squares that I'm starting with. There are 100 of these squares all together here. I know there are 10 on this side, and I know there are 10 all together on this side. And I know that 10 times 10 is 100. So 100 is going to go on the bottom. Okay, that is my denominator. Now, the one that goes on the top is how much is shaded. So if I look, I see, well, 10, 20, 30. 30 is shaded. Okay, so 30 out of 100. 30/100ths is the way this is read. And if I think of this in terms of money, I know that this is kind of like 30 cents. So I can write my decimal, 0.30. 30 cents. Some kids might wonder why it wouldn't be 0.03. And the reason is this would only represent just 3 tiny squares. It would only represent 3 of those, 3 pennies, not 30 pennies. So it's not 0.03. That answer would be incorrect. Okay, so I'm going to take a look at my others here. So for this one, this many is shaded. I don't even have one long shaded on here, so it's not even one of these. I'm going to have to use my cubes. What I'm thinking about is my pennies. And I'm going to say I got, let's see, 5, 6, 7, 8, 9. I have 9 shaded. So again, I have 100 in all, because these flats, these squares here are the same. I put 100 on the bottom, and then I'm going to put 9 on the top. So this is my denominator, this is my numerator. I have 9 hundredths. And when I read this, I want to make sure that I read it as 9 hundredths. Okay, so I'm going to say 0.09, because it's 9 hundredths. It's just like 9 little cubes, 9 cents over here. And just to go back to this one for a second, so this we said was 30 hundredths, and I wrote it that way. Another way I can read this after I have it written is, just as it says up here, 3 tenths. So one of these is a tenth, and I have 3 of them. So that also makes 3 tenths. 3 tenths, 30 hundredths. It's the same number. Now let's take a look at number 3. Number 3, I have 1, 2, 3, 4, 5, 6 all shaded. So that's 10, 20, 30, 40, 50, 60. So I know 60 hundredths or 6 tenths. And then I have 1, 2, 3, 4, 5. So 65 hundredths is shaded. And I'm going to write that as a decimal, 0.65. 65 hundredths. Okay, that's how you do those first 3. Now, this is asking which decimal is greater. Use the grids to help you. So this wants to know 3 tenths or 9 hundredths. Well, if I take 3 tenths, this is how many is 3 tenths. And then if I look at 9 hundredths, well, this is how many is 9 hundredths. I know by looking at these that this is bigger. And I also know, looking above here, this is my 3 tenths, and this is my 9 hundredths. You might be wondering why there's a 0 after this. This and this is the same number. It doesn't matter how many zeros I put to the right, it's going to be exactly the same number. 0.3 is the same as 0.30, is the same as 0.300, 0.3000, all the same number. This equals the same number. However, if I start putting zeros before the 3, I can't do that without changing the value. You can put them after, so this is the same as that. Alright, so I know that which is greater is 0.3 is greater. Now again, here which is greater is at 0.9, this one, 0.09, sorry, or 0.65, which is this one. Well, looking at the grids, I can see that 0.65 is greater. And now here, 0.3, which is here, or 0.65, which is here. Well, 0.65 is greater. Now this one, it wants you to color certain parts of the grid. So, this says 0.8, or 8 tenths. So it's important that the students know how to read this as 8 tenths so that they know how much to color in, because this tells me I'm going to color in 8 of the tenths. So there's 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths. Okay, so it should look something like that. Color in 4 hundredths of the grid. This extra 0 is here. There's 2 spaces. I know this is hundredths. 4 hundredths is only just 4 little squares. So that's it, 4 hundredths. Now color in 53 hundredths of the grid. So what I'm going to do is I'm going to color in 5 tenths. 1, 2, 3, 4, 5. and then 3 hundredths. And that makes 53 hundredths. Now, it's going to want me to use these numbers here, which are the same numbers here, and write them in order from smallest to largest. Well, I'm just going to look at my grids. I know this one is the smallest, 0.04. The next biggest would be this one, 0.53. And then the next biggest would be this one, 0.8. And that is home link 5.7, understanding decimals.